not an experiment, that's a big word, but it's a pilot experiment. So with some of the research I'm doing, we're looking into how can we restore mussel beds. And so what I briefly mentioned before is that these mussel beds, they alter their environment. So this is also why you can see at least part of them now higher up and sticking out of the water, because they create in this soft sediment world a hard substrate, right? So they hold on to each other with byssal threads, they form like a bank. They trap sediment, so that becomes elevated, and they with this hard substrate they actually reduce the wave stress. So you can, like now not, but there can be a lot of waves, hydrodynamic energy that dislodges these mussels from a sandy environment. But that's actually an environment that tiny mussels prefer. So they prefer to settle in these mussel beds because they have a hard substrate, they have a fibrous substrate, there's protection from predation, there's protection from big waves, because if you're a tiny mussel of 1 millimeter and you want to settle here and you have a wave that is coming over, you can't bury it, for example. It's also very difficult to restore them because you basically need an adult mussel bed to get new mussels, but yeah, you don't have an adult mussel bed. So what we're doing here, or at least this is after a couple of years of research, so we're like, okay, these traits that these mussel beds have, how can we use that to restore them? So you want a hard substrate that reduces predation, that also has a fibrous substrate, because they like to settle in between these byssal threads, it's a fiber. So we designed structures that are biodegradable, that should attract mussels because they have a hard substrate. That's the biodegradable plastic here mixed with wood pulp. They have this fiber, that's the coconut mat, like inside the structure.